Hello students, this is lecture 3, Discrete Mathematics, CSE230. Hope you've all understood the topics of lecture 1 and lecture 2. In those lectures we studied set theory and function, and today we are going to know about counting, permutation and combination. Many of us have already studied permutation and combination in their previous classes, yet they find it really difficult to solve the problems based on permutation and combination. So in today's lecture, we will clarify our concept and know about counting, permutation and combination. Before we go to the main topic, let us recall the concept of factorial. So, what is factorial? Let's have an example. If you take the product of all of the positive integers starting from 1 to 5, this is equal to 120, and according to the last limit of this product, this is known as 5 factorial. And this can also be written as this. And this is read as 5 factorial. Right? So, if we take the product of 4 integers starting from 1, this is known as 4 factorial. If we multiply 1, 2 and 3 according to the last limit of this product, this is known as 3 factorial. And this can also be written as this or this. So, what is n factorial? If someone takes the product of all of the integers, positive integers starting from 1 up to n, where n must be a positive integer, this is known as n factorial, right? So, can you answer if someone writes 10 factorial, what does it mean? This is the product of all of the positive integers starting from 1 up to 10. Okay? Yes. So, now we know what is factorial. So, some of us who have studied combination and permutation may have seen these kind of notations before. This stands for, C stands for combination, and this P stands for permutation. These are related to some formulae. Don't worry, who haven't seen this notation before, I'll explain all of the topics later. But if someone wants to master the topic of permutation and combination, knowing only these two formulae, I can guarantee that he can never get to learn how to solve problems based on permutation and combination. If someone wants to master these topics, permutation and combination, he has to know about counting. Yes, if someone can count well, the topic of permutation and combination will be a walk in the park for him. But counting is not as simple as counting of our fingers. This is a little advanced, but don't worry, counting is easy. So let's have an example. For example, say we have 3 pens named P1, P2 and P3. And we have 2 markers, M1 and M2. Here comes the first question based on counting. You'll have to pick any one of these 5. But the question is, in how many ways can you do that? So, this is simple, very simple to answer. You can say that someone who wants to pick a pen will pick P1 or P2 or P3. And someone who wants to pick marker will pick M1 or M2, right? So, here we see that we used the term or frequently here, P1 or P2 or P3, M1 or M2, right? So the total number of ways, in how many ways can someone pick any of these items? the total number of ways will be 3 ways from here, 3 ways plus 2 ways, right? Will be 5 ways. So how did we count that? Let's compare this scenario to another. For example, before picking any of the item, I am in a position where it is called A, and after picking one item, I'll be in a position B. So I can accomplish this procedure following 2 different tasks. This is task B and this is task M. What does this B mean? Actually, this means picking any of the pens, and this task M means picking any of the markers. So should we have to perform both of the tasks, or we can either accomplish task B or task M, right? P or M, right? So there are 3 ways to accomplish the task P. How? We'll go to here and we'll follow the link P1. This is known as P1, this is P2, and this is P3, right? Choosing pen 1 means the choosing of link 1, P1. Choosing pen 2 means choosing the link P2, right? And so on. And this is link M1 and this is M2. Someone will go there, pick either this or this way, or someone will go there, either he'll choose M1 or M2. So in the first task there are 3 ways, and in the second task there are 2 different ways. And since the relation between these 2 tasks are OR type relation, so we added the total number of ways. So here comes the first rule of counting. What it is? Since we used the term OR frequently here, and for the term OR, it always refers to addition. Okay, so if some condition is related to or the tasks are in a relationship like OR, then it will refer to addition. Okay, so there were 3 ways or 2 ways. So eventually what we did was we added all of the ways. So if we have understood this example, it will be very easy to understand the sum rule of counting. If a task can be done in n1 ways according to process A, or in n2 ways of process B, where all of the n1 and n2 ways are different or distinct, the total number of ways through which the task can be done is n1 plus n2. Someone will start from X, he will go to Y, he will have to perform either task A or perform either or task B, and there are n1 options here available and there are n2 options available. So he can go there, follow any one of these n1 options and reach Y, or he can go here, follow any one of these n2 options and reach here. So the total number of ways in which he can accomplish the procedure is n1 plus n2, right? So very simple. So now we understand what is sum rule of counting, and here we'll see another example here. Like before, we had 3 pens P1, P2, P3, and we had 2 markers, right? M1, M2. In this question, you are asked that you have to pick 1 pen and 1 marker. Careful, 1 pen and 1 marker. Okay, so if someone wants to pick a pen, he can pick either P1 or P2 or P3, and then he will have to pick a marker. He can pick M1 or M2, and here if we compare this scenario with the first one, I will have to reach B from A, and I have to accomplish task P here, then I'll have to accomplish task M here, then I can reach B. Only then I can reach B. Okay, so why is the diagram different here? Because at the first example we had to pick either A or B, right? Like this. But in this example we have to pick a pen and a marker, so we'll have to accomplish both of the tasks. So for task 1 there are options P1, P2 and P3. For task 2 there are two options. This is M1 and this is M2. Okay, so someone can pick P1, and having picked P1 he has two options M1 and M2. Someone can pick P2, and for that he has two options M1 and M2. And someone can pick P3. For it he has two options. So the total number of ways through which someone can pick one pen and one marker are 1, 2, 3, 4, 5, 6. 6 ways, right? So how did we get that? Actually, see, for P1 we had two different ways. For P2 we had two different ways. For P3 we had two different ways, right? So we actually get these 6 ways by multiplying the total number of ways of task 1 with the total number of ways of task 2. This is total number of ways of task 1 and this is total number of ways of task 2, and multiplying both of them we got 6 ways. So can we see the difference here? When the relation was OR, we added 3 plus 2, and when we see we have to accomplish both of the tasks, we multiplied it, right? So and always refers to multiplication. I repeat, and always refers to multiplication. So if we see some condition is related to AND, or if we have to perform some task A, B, C, and there are small a options here, small b options here, and small c options here, then the total number of ways through which we can accomplish the whole procedure, completing A, B, and C, will be, total number of ways will be A into B into C, right? So if we've understood this, then it will be very easy to understand the product rule or multiplication rule of counting. Here, product rule says if a procedure is broken down into a sequence of two tasks where there are n1 ways to do the first task, and for each of these ways of doing the first task there are n2 ways to do the second task, then there are n1 into n2 ways to do the procedure. How does it go? Okay, so for example, you have 3 t-shirts and you have 2 pants, okay, and you have 4 caps, okay. So if I ask, in how many ways can you get ready using all of these items? In how many ways can you do that? Okay, you can choose pant 1 or pant 2 at first, and then you can pick, having picked P1, you can pick any of these t-shirts, T1, T2, T3, right? You can pick any of these t-shirts having picked P2, T1, T2 and T3, and having picked all of these t-shirts or and pants, you can have 4 different options of caps, right? 4 different caps. Okay, so the total number of ways, in how many ways can you do that or get ready using all of those? You'll start from there and you'll reach any of these terminal points, right? So the total number of ways in which we get this will be 2 into 3 into 4. How is it? As we said that we had to perform all of this. We had to put on our pants, then t-shirt, then cap, right? So since all of the tasks must be done, so for the first task there were 2 options. This can be in 1. For the second task there are 3 options in 2, and for the third task there in 3 options. And since all of the tasks must be done, then the total number of ways will be n1 into n2 into n3. Okay, as simple as that. So if we've understood this problem, then we can easily solve this. For example, you have gone to a food corner and they offered you 2 types of pizza, two pizza, P1, P2, 3 burgers, 3 burgers, B1, B2 and B3, and 2 types of juice, J1, J2, 2 juice. Okay, so the first question is, in how many ways can you pick one item out of this? First question is, pick one item. So this is really easy, because how you can pick any pizza, and for picking pizza there are 2 different ways. Or you can pick a burger, there are 3 different ways. Or you can pick 2 juice and 1 juice. So there are total 2 ways. And since the relation between all of the tasks related to or, that means you'll have to add all of these options according to the sum rule of counting, right? So there are total 7 ways in which you can pick one item out of this 7. So this is easy. So now if I ask you that in how many ways can you pick one pizza, you have to pick one pizza, or you can pick one burger plus 1 juice. Let me clarify the question. For example, you can pick a pizza, and if you take a burger, the rule of the restaurant is you'll have to pick a juice with that. So in how many ways can you perform this procedure now? Okay, we can compare this scenario with this. At first you were in a situation when you were hungry, and after taking this food you will be satisfied. So your target is to become satisfied with the food. So how can you perform this procedure? You can go and complete this first task of P. What does P means? It means, sorry, there were 2 different things. Okay, completion of task P means choosing P1 or P2, or you can go to B by completing 2 tasks here. How? At first you have to pick a burger, then you will have to pick a juice, and there are 3 types of burgers, so there are 3 links you can follow here, B1, B2, B3, and there are 2 juice available, and there are J1 and J2. So you can follow either this procedure the upper one or this. And since here in this case, in the first case, there are two ways how you can satisfy your hunger, and here there are three ways into two ways, so total six ways here, right? How? Because here you have to perform both of the tasks, and there for the first task there are three options, for the second task there are two options, so the total number of ways through which you can choose a burger and a juice is 3 into 2 ways, right? So the total number of ways will be 8 ways. You can ask, why did I put plus sign here? Because I'll perform either this task or this task, right? So since the relation is related to or, so I added both of the number of ways. So that is the end of this segment. Hope you've understood all of the problems and sum rule and product rule of counting principles.